the topic at hand here. It is a bit of a mouthful, as I heard you saying it earlier, it has a pretty impressive density of buzzwords in it, if I do say so myself. However, this really comes down to kind of the things that are becoming practical with confidential computing, and outside of a lot of the discussion in the past has been around securing your own workloads so that you can run your data that you may have run on-prem and just running it somewhere else and being able to verify it's running correctly for you. But I think things get really interesting when we start adding additional parties with the computation, and something that I think is the confidential computing adds a lot of flexibility to. That will bring me to my first slide here. In a very stripped down, oversimplified scenario here, you can just imagine that there are two different people, one of which owns data. Their core business is collecting that data, being stewards of it, and providing the benefits of having that data. Whereas someone else on the right-hand side here, the consumer, wants to get some sort of information out of it. They have a business that needs the insights that data may provide. This is something that has been done in the past. However, the situation is a bit more complicated than I've expressed here. And if I go ahead and add a little bit more of the complication, obviously, when you're doing this, somebody needs to actually be running the code that does the processing of the data, that takes this input information, distills it down to the insights, and provides it to the data consumer. And someone needs to write the code that is doing that. And in the past, without confidential computing, this has really kind of forced some of these roles to be overlapping in ways that are not perhaps desirable in the given space. Like, since you didn't want to provide all of the information to the data consumer, you might have to become the processing owner yourself as the data owner, whereas you may not really want to be in the core business of having a fleet of servers and keeping them maintained and protecting the security of access, because that's not what you're all about. And likewise with somebody writing the code, you may not be a software development firm. But one of the things that confidential computing really lets us do is with the additional controls and restrictions that are placed on that center box, the processing, it really allows a lot more flexibility on how we arrange this work. And the reason why you want that is when you start layering in the motivations that the different roles in this system may have. The data owner, as I said before, they're really about, they own this data. They really want to lock it down. They want to protect it, even at the expense of potentially making it harder to use or harder to access. The data consumer really wants those insights. They would err on the side of wanting to make it easier to access, because that's what they need to do, and they don't want to, they want to remove as much of that friction as they can. And then you have, the code author who wants to ensure particular functionality, maybe adhere to certain regulations, being able to make some guarantees about what the code does. And then the processing owner, it's that they have to run the actual fleet of machines, but they're really interested in the cost of the system, because compute costs are a significant factor, and they would have the motivations to reduce those costs, and even not speaking of any kind of malicious intent, just even completely in good faith, they would be apt to lean towards perhaps cutting some corners in order to reduce those costs and still be able to provide a product for the other people in the system. So this is where I think there's a big opportunity for the flexibility that confidential compute provides. And so here I've added confidential computing. It doesn't change the diagram dramatically. However, you can see that the processing part now has some additional restrictions. I've drawn it as a safe here. But the key bit here is the attestation. The attestation coming out of that system can provide guarantees on what the execution environment looks like, the fact that it is a safe and not just a box as before, and also what's running. The code that is running can be verified that it is the code that they have approved, whether that be through some sort of code audit themselves or through some trusted party that does these audits. They can get reference measurements that say what code should be in there and should I trust it. And what this does is it allows, when we compose these different roles into different actual actors, it opens up some really cool use cases in the space of like multi-party compute. I'll go through a few of those now. So as a simple starting point, we start with the same diagram I had before, with the data owner on the left and the data consumer on the right. However, this allows the motivations to be aligned properly. The ones that are getting the insights and want to run the code often are now actually owning the processing and having to pay for the cost of the processing that gives them those insights, while the data owner can stick to just providing access to the data only when acceptable, and defining, through writing the code on what they're allowing to do. They wrote the code so they know that it won't abuse or misplace their data on the other side. This can, of course, because of the flexibility that I mentioned before, become multi-party on the roles as well. So both sides of the exchange can now be contributing data and consuming data, which means that you could have two parties that could even be competitors in a space, but they want to be able to combine their data sets, get the insights from each other without actually losing control of the data, because the person they're talking to would have a material interest in gaining access to it. So here you have both parties providing data into the system, both parties receiving insights out of the system, but no actual loss of control of their own data going in there as well. And finally here, another example would be to align interests. As I said before, not everybody wants to be in the business of writing code or executing the TEE. You could have the multi-parties here, and in this case, it would scale. You could have any number of people who are data owners and data consumers, all submitting their data to a central kind of data collection piece that is run by a business that's their core competency. They create the environment that is secure, and they also run it while being able to provide these guarantees through attestation. So it would allow companies that maybe otherwise wouldn't be able to use this kind of arrangement to use it and still be able to trust that their data is not being exposed. Okay, and I did mention that this was about kind of the use cases that are being unlocked in this space. However, I would be amiss if I
Keith?
did. Yes.
I'm not sure if you can hear me, but we have some audio issues.
Oh.
Maybe you can try to close your video so that we can hear you better.
Sure.
That would be perfect. Okay, thank you.
All right.
Serving
Hopefully you can hear me now.
I think it's better. Yes. Go further.
Great. So I would be remiss if I didn't, give a shout out to what I've been working on for some time now, with confidential space. This is a GCP's entry into the TE space. It's built on top of our confidential VMs product that's been out for a while. We view this as unlocking these different use cases that I've mentioned before. It allows for a kind of simple deployment of being able to do these things. It is open source, so that people can have confidence in the parts that Google has provided here. And it's built on open standards. And I think this is important because it allows for opportunities for interoperability between products, as well as ease of use for things like being able to use standard containers as the deployment mechanism instead of some bespoke format or deployment. And let me get back to you. my slides. And further, we've provided a lot of things for people that are willing to trust the cloud a little more. Some usability add-ons that make it so that you don't have to do a lot of the complication of confidential computing yourself. There is an attestation verifier service that provides a much simpler attestation than a raw TEE. It directly integrates with Google IAM, which means that you can protect kind of arbitrary Google Cloud resources with the attestation properties of your system. And you can write the policy around what is acceptable for those resources in a standard, very simple policy format.